Hey guys, so yep, the last 2 days I wasn't here, but we had the videos over 2.5. We're going to go back over some of that, not the whole thing, but go over parts of it just as a refresher, just kind of answering questions or just making some things clear. Because 2.5, this is really our start of solving these higher degree polynomial functions. And we went over this here, different ways to solve, because we had factoring, graphing, completing the square quadratic formula. And the completing the square and quadratic formula, we needed it to be a degree 2 polynomial function. The biggest exponent is 2. And for anything that's bigger than that, we needed to find a certain number of the solutions and use synthetic division to reduce the degree down from, say, 4 to 3, from 3 to 2. And then we could use quadratic formula or completing the square to solve from there, or the square root method. So if we look this here, all right, guys. So this one here is just the first one on the note sheet. 2x cubed minus 12x squared plus 18x equals 0. And we could, well, these here we went through factoring. I'm not going to worry so much about the factoring. I'm just going to start with this one here. And this one here, negative 2x to the fourth plus 16x squared minus 32. If I remember right in the video, we went through and I factored it and did the process of that there. We can also graph it. Because if we graph it, we can pull the graphing calculator up and hit y equals. And we could type it in, negative 2x to the fourth plus 16x squared minus 32. And we hit graph and we get this here. And again, when we solve, we're looking for what values of x will make the y be 0. Because when we graph, we solve, we're finding the zeros, we're finding the solutions. We're trying to find out what value of x is going to make the y value be 0. And there's two of them that we have here. We have negative 2 and positive 2. So we have two solutions. And from here, we can use synthetic division. So our coefficients across the top, we'd have negative 2 for x to the fourth. Since there's not an x to the third, it would be 0. 16 for x squared. 0 for x, since there is no x to the first. And negative 32. Now, does anybody have a guess of what the remainder is going to be here? 0. Because again, according to the remainder theory, which we had on Tuesday with our synthetic division, the remainder when we do synthetic division is the same as if we plug the number into the function itself. So if this, say, 2, we'll start with 2, is a solution, the y value is equal to 0. If we plug it in, it should equal 0. So if it is a solution, the remainder should be 0. And that's one way we can tell if it is a solution. So we'll do synthetic division with 2. We bring the negative 2 down. 2 times negative 2 is negative 4. 0 plus negative 4 is negative 4. 2 times negative 4 is negative 8. 16 plus negative 8. 16 minus 8 is 8. 2 times 8 is 0 plus 16. 16 times 2. Negative 32 plus 32 is, it means it is a solution, yes? What other solutions did we have? Negative 2, yes? We could rewrite this whole thing down and do it again, but what numbers would we end up using across the top? Negative 2, negative 4, 8, and 16, yes? Why rewrite it if I can just put our cubby next to it, draw the line, and use those numbers right there? We don't necessarily have to rewrite it. So the negative 2 comes down, yes. Negative 2 times negative 2 is 4. Negative 4 plus 4 is 2. Negative 2 times 0. 8 plus 0 is negative 2 times 8 is And negative 16 plus 16 is 0. Do we have any other solutions that we got from the calculator? No, but we do have this equation here. So we can go on and plug the variables back in. Because this is our remainder, 8's our term without x, 0 is our term with x, and negative 2 is our term with x squared. So it tells us negative 2x squared plus 8 is equal to 0. Questions on this so far? Because I think we definitely did this one in the video, yes? And I think, okay, so I did graph it. I didn't go about factoring it. Now, because there is no middle term, we can use the square root method. Because if we had negative 2x squared, an x term, and then 8, quadratic formula completing the square. This is kind of nice. Because at this point, we can subtract 8 from both sides. Telling us negative 2x squared is equal to negative 8. At this point here, we can divide both sides by negative 2, telling us x squared is equal to 4. And last but not least, we take the square root of both sides, telling us x is equal to plus or minus 2. So we already had that x is equal to 2 and negative 2. But this is also telling us that x is equal to 2 and negative 2. We have two solutions at 2 and negative 2 that repeat how many times? Twice. There is something called an even multiplicity with these polynomial functions. An even multiplicity. And what it means is that if a graph intersects the x-axis but does not cross it, it has an even number of zeros at that location. So at negative 2, if we look here, it does look like, and it indeed, it touches the x-axis but does not cross it, which means there's an even number of zeros at that location. So at 2, there's 2 2's. At negative 2, there are 2 zeros there. We can have more than one. If it crosses the x-axis, it has what we call an odd multiplicity. There's an odd number of zeros at that spot. What is the smallest odd positive number? Yeah. So yes, the smallest odd positive odd number is 1. So if it crosses the x-axis, it could have one solution. But it could also have 3 or 5, 7, 9. It just means that the number of zeros at that spot is an odd number. Most likely we stick with 1. Most of the time it is 1. But it could be 3. Does that make sense? So if we did find a solution and it crossed and it said that x is equal to 1, x is equal to 1, there's a good chance it's 1 more time. It gives us an idea of what solutions that we have. So we can look at this here. Because hopefully this is starting to make a little more sense, yes? And a lot of what we're doing with 4, 5, and 4, 6, because we're going to do more solving with 4, 6, is we're trying to find solutions. So what we're doing here is we graph it, we find solutions, and remove them. Because as I remove solutions, if I put the variables back in, because here, the biggest one was x to the 4th, x to the 4th. When we did one division, remainder, term without x, term with x squared, x cubed, the degree decreased by 1, yes? No way to solve a degree 4 without factoring or doing stuff to it. But since I did find one of the solutions, I took it from a degree 4 to a degree 3. When I did it again, it took it from a degree 3 down to a degree 2. So if I can find at least 2 solutions by graphing or some of the methods we'll have, I can at least solve a quadratic formula. Or if I get 3, that's even better, because it would take it from a degree 3 to a degree 1. We just have x. So let's look at the next one here. X to the 4th minus 18x squared plus 81. I'm just going to grab the calculator. X to the 4th minus 18x squared plus 81. We have this here, yes? We see it comes down, it hits the x-axis and goes back up. And the two places it hits the x-axis are what? -3 and 3, yes? So, again, we don't have a good way to solve fourth degree polynomial functions. But the graphing calculator did tell me that -3 and 3 are solutions, yes? So we have two. There are two more. So we can do synthetic division to help get us to something that we can solve. We can get it down to a degree 2. Now we have 1 in front of x to the 4th. There is no x to the 3rd, so it is 0. X squared is -18. X is 0. And then we have 81. Bring down the 1. Which one do we want to try first, 3 or -3? 3. Put it in the box and we're going to do synthetic division. 3 times 1. 3. 0 plus 3. 3 times 3 is -18 plus 9. Almost. -9. 3 times -9. -27. 0 plus -27. 3 times -27. -81. 0. But again, this whole synthetic division, we can do each of the steps in the calculator. Can't do the whole thing because I can do 3 times 1 in the calculator. Enter. Gives me 3. I put it up there. Plus 0 is 3, so I bring it down. Multiply by 3. Multiply, add, multiply, add. The calculator can do that. And we get this here, and because we have a remainder of 0, it tells us it is a solution, yes? Now, what did we just say about even multiplicity? If it touches the x-axis but doesn't cross, there's a good chance that there might be a second 0 there, yes? So let's just check and see. Let's try 3 again. 3 times 1 is 3 plus 3. 3 times 6. 18. You're good. 3 plus 6. -9 plus 18. 18 minus 9 is 9. 3 times 9. -27 plus 27 is. So wait a minute. 3 doesn't work just one, it works twice, yes? So that means one of our other solutions is indeed 3. We have 3 twice, yes? Well, could it work a third time? Maybe. Probably not. Because we do have another solution. We have what? -3. Let's try it. -3 times 1 is 6 plus -3. -3 times 3 is. Questions on what we've done so far? It is a good number of steps, but for the most part, the steps in and of themselves aren't totally bad. Yeah. Because if we started with -3, I'm going to erase all this here. Because 1 times -3 would be -3. 0 plus -3 is. -3 times -3 is. And 18 plus 9 is -9. 3 times -9 is positive 27. 0 plus 27 is 27. Gives us -81. We still get the same spot because if it is a solution, when we do the synthetic division, the remainder will be 0. If it worked on 1, it doesn't matter where in the process it will work again. If it doesn't work in one of them, it won't work in the rest. Because if it's not a solution for one of it, it's not a solution for all of it. Does that make sense? And we could do the same thing going through. Now, coming back up to this here. Now, when we started out, as we said, the degree decreases. It was a degree 4, so we do a synthetic division, we finish. Our new one's going to be a degree 3. We did it again, which is going to reduce it to a degree 2, yes? We did it one more time, now it's a degree 1. And at this point, we could do synthetic division again. But as a degree 1, we're just saying that x plus 3 is equal to 0. Yes, because we would subtract 3, which is telling me that the solutions are, indeed, 3, -3, 3, -3. They both touched the x-axis and went back up. Those are our solutions. Questions on this here? So we're kind of seeing how this is working together. We're trying to find ways to get the solutions to decrease that degree as far as we can and then go from there. Now, some of them, there are some that we're literally going to have to use factoring because they're irrational. They're complex solutions. We can't get them any other way. We're not going to delve too far into that. Most of what we have, we can solve using the graphing calculator. Now, I believe this was yesterday, the rational zeros, plus or minus p over q. Rational zeros, this theorem will give us every possible rational zero that the function could have. So if it's a rational zero, if it can be written as a fraction or as a whole number, this will give it to us. P is the factors of the term without x. Q is the factors of the term in front of the variable with the biggest exponent. So if we look at this here, we want to find all the real solutions of this here. We're going to find the rational zeros here. So the first thing we need to find is the factors of P and the factors of Q. P is the term without x. So what is our term without x here? 20. Factors of 20. Well, we'd have 1 and 20. 2 goes into 20, yes, and it's 2 and what? 2 and 10. So 3 is not a factor, 4 is, 4 and what? So all the factors of 20 are 1 and 20, 2 and 10, 4 and 5. Questions on this so far? Q is the factors of leading coefficient. So what is our leading coefficient here? 1. Well, the only factors of 1 are, question on how we found P and Q. Because I think some of you all might have been a little confused with this here, yes? So, I mean, watching it yesterday. Now, rational zeros, plus or minus P over Q. What we do is we take every factor of P and divide it by every factor of Q. And I always start with the smallest value of Q first, which is 1. So, okay, we'll have plus or minus 1 divided by 1. Plus or minus 2 divided by 1 is 2. Then we're going to do 4 divided by 1, 5 divided by 1, 10 divided by 1, and that is it. Now let's just say that instead of just 1, it had Q was 2. You guys ready for this? So we finished with 1. Now I move on to 2. So I put plus or minus 1 divided by 2, 1 over 2, which would be almost 1/2. Then we would move on to 2 divided by 2. 1, is it listed? If it's listed, we don't repeat it. Then I move on to 4 divided by 2, 5 divided by 2, 6, 10 divided by 2, 20 divided by 2. And then we would just keep going with each factor of Q. Okay? Does that make sense how we found the P over Q? And the reason this is helpful is it gives us an idea of what rational zeros we have. So if there's a rational zero, if there's a fractional number we can plug in, it's going to be in this list. 1, -1, 2, -2, 4, -4, 5, -5, 6, or 10, -10, and 20, -20. One of these is going to work. All right? Questions on this here? Yes. Now, the pure math way, and y'all saw this, I think, in the video as well. If it's a solution, that rational zero must have a remainder of 0 when we do synthetic division, yes? The pure math way is that we start with 1. And if 1 gives us a remainder of 0, it works. If it doesn't, we throw it out and then move on to -1. So I would watch this first one here because we'd go 1 times 1 is 1. -8 plus 1 is -7. 1 times -7 is -7. 11 plus -7 is 4. 1 times 4 is 4. And 4 plus 20 is 24. Is that a remainder of 0? Nope. So that means +1 doesn't work. All right, so +1's out, which means we would move to -1 and try it again. Oh, apparently -1 times 1 is -1. -8 plus -1, -9. -1 times -9 is 11 plus 9. -1 times 20 is which gives us a value of, well, it could work twice, so we could try it again, see if it works. It won't. So it only works once. So that tells us one of the solutions is -1. Then we could try 2, -2, 3, -3, 4, -4, 5, -5, 10, -10, 20, -20, and see which one works. That's a lot of guess and check, yes? Questions? At what point? So do you understand how we got P over Q? Do you understand factors of P? P is constant term, factors of 20. What's factors of 20? Factors, 2 things multiply together to give us 20.
Yes.
What multiplies together?
1 and 20, 2 and 10, 5 and 4.
That's it.
Oh.
Factors of leading coefficient, the number in front of the variable with the biggest exponent. Well, that number is almost, because x cubed. Yep. So 1, yes? That's how we get Q. P over Q, the possible rational zeros, the ones that will give us a 0, is we take each P and divide it by each Q. So 1 over 1 is 1.
Where's the term P and Q?
So it's just set, they just gave it P and Q.
I mean, like, what?
So P is the factors of the constant term, the numbers that multiply together to give us 20. Q are the factors that give us the number in front of the biggest, that leading coefficient. And we're going to take P, each factor of P, and divide it by each factor of Q. And we do it one at a time. So we divided 1 by 1, 2 by 1, 4 by 1, 5, which just gives us 1, 2, 3, 4, 5, 10, 20. And we put plus and minus in front of it because it could be positive or negative. And this is just theorem. Now, if we do synthetic division and get a remainder of 0, it is a solution. It has to be a solution. It has to work. So then we just tried 1. Got 24, didn't work. -1 gave us a remainder of, so it is a solution. Then we could try -1 again and see if it works. If it does, it's another solution. If it doesn't, we move on to +2. If it works and gives us a remainder of 0, it's a solution. If it doesn't, it's not. Then we move on to -2, 3. Yes. Or if we come to the graphing calculator, I hit y equals. The function is x to the 3rd power minus 8x squared plus 11x plus 20. We get this graph, yes? Graphs here and there. But I'm looking for what value of x will make the y value be 0. Well, there it's telling us it is what? -1. Which we did already find, yes? Now it crossed 2 more times. Let's scroll down. The other 2 are? Were they listed in our group? Yeah. So if I wanted to, I could do 4 next to make sure this does work. 4 times 1 is 4. Negative 9 plus 4 is 4 times negative 5 is. It is a solution. And that leaves us with x minus 5 is equal to, if I solve, add 5. So our solutions are negative 1, 4, and it gives us ways to find these values. Because that's all the rational theorem is can I get zeros? What are the zeros? What are the rational zeros? Does that kind of make sense? In the first part of the homework, because I think most of y'all got the homework sheet. Yes, that worksheet. 1 through 3. Problems 1 through 3. That right there is all it's asking for, P over Q. You don't even have to solve it. Don't solve it. Most of them, the numbers aren't rational. I just made equations up. I just want you to find the P over Q. Plus or minus P over Q. That's all you're finding. On the back half of it, the solutions, I'd start by graphing it, finding your zeros. Finding what values of x will make that function be 0. Okay? Let's see here. I think we're doing fine on time. But is that starting to make sense? Because the whole thing with this, there seems like there's a lot to it, and there are other steps and other things to it. Because there are problems that are out there, x to the 4th plus 9x, or 18x squared plus 81. Something like this here, where if we go and graph it, x to the 4th plus 18 x squared, apparently I can hit the right arrows, plus 81, it doesn't intersect the x-axis. We have to do other things to solve them. We're not going to get into those too much. All the ones we'll be doing and covering, you will be able to find at least enough zeros to get it to a quadratic, get it to x squared. Because then we can use the quadratic formula and solve. This here ends up, we have to factor it. And this ends up being 3i, 3i, negative 3i, negative 3i. It's imaginary solutions across the board. It wouldn't graph, it wouldn't function. We had to factor. But we're not going to delve too far into that there. Okay? So do we feel kind of more comfortable with 4, 5? So let's look at this one here, example 4. Well, and especially on the test, the first thing I would do is just graph the thing. Type the whole thing in and graph it. We get this here. I'm going to take some of the thunder away from 4.6. One of the things we're going to cover in 4.6 is the fundamental theorem of algebra. There's two main parts of it. I'll tell you the main part that's kind of important for us here. The degree of a polynomial function is equal to the number of zeros. So the degree of this was, so it should have how many zeros? 4. Yep, so this should have 4 zeros. How many times does it cross the x-axis here? It means each one of those zeros is going to show up once. All of these are between negative 10 and 10. Specifically, they're between negative 2 and 4. Let's look at the table. You have a single zero that shows up here. Yeah, so we have the y-intercept. But we're looking for the x-intercept. We're looking for what value of x makes the y value be 0. Do we have a single one here? No. Okay. This is where the rational zeros theorem comes into play. And it's very nice because, again, I said that there's going to be at least, especially here, 2 rational zeros. All the ones we'll be doing on the homework and the test, there will be at least enough rational zeros to get us to a quadratic. Here, there's 4 solutions. I need 2 to get to a quadratic. P, in our case, is what? What number is going to be P that we're looking for? Factors of what? 12. Factors of 12. So 1 and 12. 2 and 6. 3 and 4. So factors of P, factors of 12. Q, what is our Q number? 10. So we're looking for factors of 10, which is 1 and 10, 2 and 5. Plus or minus P over Q. Guys, let's focus up here. Focus up here. So this is the first one we've done because the video did more of these for plus or minus P over Q. I always start with the Q value of 1. So we're dividing all the factors of P by 1. Well, what is 1 divided by 1? 2 divided by 1. 3 divided by 1. 3. 4 divided by 1. 6 divided by 1. 12 divided by 1. 12. Because we really just, with 1, we get all those numbers back. We're just adding a plus or minus in front of it, yes? Okay. Then I move on to 2. So we're going to do 1 divided by 2. So we have plus or minus 1 over 2, yes? Okay, I'm going to get the eraser here. And for these here, especially once we get past 1, you can throw these in a calculator. Because the next one would be what? 2 divided by 2, which is it listed? I don't have to list it twice. 3 divided by 2 does not reduce, it's just 3 over 2. 4 divided by 2 is it reduced, it is up there, we're not listing it again. 6 divided by 2 is 3, it's already there. 12 divided by 2 is 6. Well, part of the reason it did reduce as well, 2, 4, 6, and 12 all have a common factor of 2, so it's going to reduce, yes? Does 1, 2, 3, 4, 5, 6, and 12 have a common factor with 5? No. So when we go through this here, 1 over 5 is just going to be plus or minus 1/5. 2 over 5 is plus or minus 2/5. 3 over 5 is plus or minus 3/5. 4 over 5, plus or minus 4/5. 6 over 5, plus or minus 6/5. And lastly, 12 over 5 is plus or minus 12/5. We're just putting them over the top of each cube. Does this make sense? A lot more than it did yesterday. We ready for the last one, 10? Well, we'll start with 1 over 10. Yes. Yes. 1/10. 2 over 10 is 2/10 or 1/5. And with any of these here, we can take a calculator, 2 over 10. 1/5, we have it. 3 over 10. 3/10. 4 over 10 is going to be 2/5. 6 over 10 is 3/5. 12 over 10 is 6/5. The calculator will tell us, and if it is already there, we don't list it twice. Questions on how we found this here? Now the whole reason is why. Yes? When we graphed it, how many zeros did we find? 0. We didn't find any. Because if we look back, this here, we said that it could be 1, 2, 3, 4, 6, and 12, yes? None of this gave us a y value of 0. Bray. Guys, up here. Okay, it's up here. If we look at the negative cases, -1, -2, 3, 6, -12, none of those gave us 0. Well, you remember when we did the one just previously for us to test to see if it is a 0? Well, I would come over here, set up synthetic division, put our 10, -11, -42, 7, 12, and we'd start with the first number, which is +1, then -1, +2, -2, and go through all these here, yes? Looking straight at the graphing calculator, well, it told me 1 and -1 did not give us 0. It told us 2 and -2, 3 and -3, 4 and -4, 6 and -6, 12 and -12. None of those gave us a y value of 0. I just removed 12 possible rational zeros from the board already.
Okay. How it shows in increments.
Yes.
Change it like that.
Yes. So to do that, we would go second window, second table set. The first one's table, the second one's increment. So we could say 1/5. Why did I pick 1/5? Well, out of all of our possible ones, the fifths, we have a few, yes? Second table. Well, we're going to have to get really close to 0. Okay, I'm going to go look at the graph. We're going to hit the graph here. So we have these points, yes? Because if we forget how to do the table set and change it, looking at that there, we have in between the notches, yes? One of them, if we look at the positive side, is between 0 and 1 and close to 1, yes? Then we also have one between 2 and 3. Well, hey, 2 and 3, that's a big number. 1/2 is either between 0 and 1, 0, -1. 3/2 between 1 and 2. 1/5, 0 and 1. 2/5, 0 and 1. 3/5, 0 and 1. 4/5, 0 and 1. 6/5, 1 and 2. 12/5 is between 2 and 3. 1/10, 0, 1, 3/10, 0, and 1. So 12/5 is between 2 and 3. 1, 2. So 12/5 might be a solution because that would line up there. Yes.
I see 0.
Yep. 12/5. .6, which would be what? 3/5.
I'm a genius.
But again, these give us an idea because 12/5 is between 2 and 3. We could try positive 12/5 first because that lines up with the graph and see if it gives us a 0. It gives us an idea what the rational zeros could be. And we can go from there and guess and check to narrow it down. Now 3/5, guys, now we have to do it with synthetic division to reduce this down. Now, I have a feeling most of y'all don't feel 100% comfortable with doing fraction multiplication, but again, it's not bad. 3/5 times 10 is 6. Then what do? We add what? Add -11 to it and get what? Guys, right up here. -5, yes? And that would go where? And then what do we do next? We multiply by times 3/5, which is -3. Then we add what to it? -42, yes? Plus -42 is -45. Then what do we multiply this by? 3/5. So I can grab the calculator and say times 3/5 and get Negative 27. Then what do we add to it? Plus 7. And then we multiply by? So can we technically plug the whole thing in the calculator? Yes and no. Yes, because we just do each step, multiply, add, multiply, add, multiply, add. Gives us the answer. Does that kind of make sense? Does that make synthetic division a little bit nicer than you already thought it was? Because even if we get fractions, multiply, add, multiply, add. Yeah. I'll be nice to y'all. Let's try 1/2. More specifically, negative 1/2. Negative 1/2 times 10, I'll tell you, is negative 5. Now, negative 5 plus 5 is negative 10. Negative 1/2 times negative 10 is positive 5. Negative times a negative makes positive. Half of 10 is 5. Negative 45 plus 5 is negative 40. Negative 1/2 times negative 40. Negative times a negative is a positive. Half of 40 is. So that tells us that x is indeed equal to 3/5 and x is equal to negative 1/2. Questions on how we found these two? Yeah. Which is good. Now at this point here, we could go through all the other zeros. None of them are going to work. The last two are not fractional. But we do now have it as a quadratic, and we can solve from there. We can solve the quadratic. Before we start solving the quadratics with factoring anything, is there a number that goes into all three terms? If there's a greatest common factor before we solve, get rid of it. 10x squared divided by 10 is x squared. Negative 10x divided by 10 is x. Negative 40 divided by 10 is negative 4. 0 divided by 10 is 0. It's going to be so much easier to find the solutions from here than it is from 10x squared minus 10x minus 40. Because here, a is the number in front of x squared is 1. B is the number in front of x, which is negative 1. And C is our negative 4. Because if we use the original ones, A would have been 10, B would have been negative 10, C is negative 40. They would have been a lot bigger. It would still get the same answers. We would have to reduce. Quadratic formula. Negative b plus or minus the square root of b squared minus 4ac all over 2a. So we have negative. Our b value is negative 1. b squared minus 4 times a times c all over 2a. Because we're just plugging in a, b, and c. Kind of like what we... Plus and minus, yes. Now, plugging this onto the calculator, we do need to be a little careful with, because the 30xs will leave it in radical form, which is what we want. But if inside that calculator, so that inside that radical, the negative 1 squared minus 4 times 1 times negative 4 gives us a negative number, the 30xs can't do it. You can't deal with complex numbers, our I. The graphing calculator will give you an answer. It will give you the decimal. We want it in radical. But here, negative 1 is what? 1, plus or minus. 1 times 2 is 2. Inside here, pull this. Come on. Parentheses, negative 1 squared minus 4 times 1 times negative 4 is. and we'll need to take the square root of it, see if it reduces. So those are the other two, because positive, negative square root of 17, so those two, 3/5 and negative 1/2. Those are our four solutions. So does that make sense? In all the problems, we will have enough to get us down to a quadratic where we could find the other two, either rational, irrational, or complex. I'm hoping this makes a little more sense. We'll do more solving with 4-6 next week and delving more into this. The only last part I want to talk about is this here, the irrational complex or irrational conjugate theorem. There's a lot of words up here, but it's not a lot to it. What this says is if a plus the square root of b is a solution, a minus b is also a solution. So if I told you that for equation 2 plus the square root of 5 is a solution, it means that 2 minus the square root of 5 has to be the solution as well. If I get one solution with a square root, I have to have another. They always come in pairs of 2. It also means that if I said x is equal to negative square root of 19 is a solution that is a value that works for this here, well, it means that x equals square root of 19 is also a solution. We have to have the positive and negative with these radicals. They always come in pairs of 2. Okay? But that's where we'll stop for that there. Now, again, that worksheet, front half, P over Q. Find the factors of P, factors of Q, and we divide them. The back half, solving. And you'll have time next week to work on it, especially the worksheets. But I'd be just grabbing the graphing calculator first, graph it, solve. Desmos graphing calculator will graph them. You just have to type them in.